Cornell, editor of Dairy Reporter, and this week we're back with 3 interviews with NIZO, NZMP and Tetra Pak. And amazingly, I even have 2 interviews already done for next week's podcast, plus 1 more planned, as well as interviews already set up for the week after that. And then it'll be May and Vitafoods, and then there's the Free From Expo in Barcelona, and maybe a few months after that Brexit, as if we haven't had enough of that hanging over our heads like the sword of Damocles. And we still don't know what's going on. But I do know what we have lined up for you on the podcast this week. We have interviews with Robyn Eijlander from NIZO on the Dutch company's work on the relationship between spores in milk powder and predicting spoilage in UHT milk products. Eric Morrison at Fonterra's Ingredient Division, NZMP, about refreshing its risk and commercial solutions, and to Martin Engdahl at Tetra Pak about the company's connected packaging platform. And we have a weekly look at the global dairy markets with INTLFC Stone's Liam Fenton. And so it's to the Netherlands for our first feature this week to talk about a practical and reliable microbial method to measure heat-resistant bacterial spores in milk powders. Robyn Eijlander is Senior Project Manager Microbiomics and Food Safety at NIZO, and I asked her how long they've been working on this topic.
The issue with spores in UHT products has been around for decades, so it has been studied for a long time. But in the consortium setting, we started off in 2013. We basically noticed that not only do you have an issue with spores in ingredients or in products, but also in what methods do you then use to detect them? How do you interpret the results? So that is a separate issue that comes along with it. And once you notice that this issue is shared by quite a few companies that we do research for, we thought it would be more powerful to stick the heads together and to, in a pre-competitive setting, study this issue together. And that started out in 2013.
And how was the consortium put together in terms of the makeup of the companies and yourselves?
Yes, so we do research for quite a large group of dairy companies, and once we noticed that this is a common problem that is shared, we basically did acquisition amongst our key accounts that we do a lot of collaborations with, and just assess their interest to join us in this pre-competitive consortium. So we were more the initiator, but also the coordinator. And we were also as NIZO, the actual company performing the work, whereas the other companies, they contributed both in kind, so with materials, with knowledge, as also cash to make sure that we could perform all of the research associated with it. So it was really a joint effort coordinated by NIZO.
So how does that work in terms of the other companies? Do they then use the results that you have come up with or the end product?
Definitely, but it's always been the idea of the complete consortium to publish the results. The main driver behind all of this was not only to increase our understanding and see how the results from our research could benefit the companies that were part of this consortium, but really also to get the word out and to increase the communication in the entire dairy market on what kind of methods are being used, what are the implications if different methods come with different outcomes and different interpretations. How can we improve the communication between producers of dairy ingredients such as milk powder and the consumers, so the buyers of milk powder basically. So it's always been the idea to publish this in an open source. And that's why we did a peer-reviewed publication in the International Journal of Dairy Technology. In that sense, all companies can benefit from our findings.
And what were the findings of the research?
Well, there were multiple. The first thing that we started off with was an inventory. So when you have spores in milk powders, the first questions we had also for the partners in the consortium was what kind of methods do you use to detect them? And to enumerate them for your risk assessment when it comes to spoilage of UHT dairy products. So we did an inventory on what kind of methods were being used, and then you need to think about which heat treatments, but also which cultivation medium, which incubation temperatures, how do you interpret the results. And we also did an inventory on the type of spore-forming species that are often encountered, and what are the most problematic species that we're dealing with when it comes to spoilage issues. So coming from that, we had quite a clear overview of what to really direct our research to. The first thing we did was to test the recovery of the media that were being used in the different methods, connected to which species are most commonly found. So we had 16 different bacterial species that form spores that are often encountered in the dairy environment. So this can be either milk powders, but also, for instance, farm environments where the introduction of spores actually takes place. And we tested their recovery on 6 different plating media. And in that sense, one of the most important findings is that one of the media that is often used at certain companies did not support the growth of such spores at all. There is also a standard method already out there, an ISO method, specifically for the recovery or the detection and enumeration of very heat-resistant spores. And that uses a medium that also did not support growth of all of those different species. So the most important finding in that sense is that the TSA medium supported the growth the best. So there's never one medium that is optimal for all species. We were able to optimize that a bit. So that was one of the most important findings. And then also one of the directions we wanted to move towards was there is an ISO method, but it's not commonly used. And why is that? And one of the reasons for that is that it requires heating at 106 degrees. And for a lot of companies or labs, this was an issue because you need specific equipment to reach such temperatures, either oil baths or pressure pans. And not every lab has this, or there are certain safety issues involved in that, specifically when you're using oil baths. And it's more difficult to really get this temperature correct. So what happens in practice is a lot of labs use 100 degrees. But of course, if you heat at 100 degrees or at 106, you will get different outcomes. So we really wanted to see whether we could offer a more practical alternative method next to this ISO method and see if we could improve the standardization. So the next step in this consortium project was to compare the results of using the ISO method and a more practical method with heating at 100 degrees and then plating on TSA, using milk powders that were collected by all of the consortium members, and to see whether we could get similar results, what the differences were. Do we have the ability to translate the analytical results from one method to the other, and what type of species do we encounter? So the most important finding of that direction was that both methods perform similarly, provided that you adjust your specifications, and that's really the interpretation of the results. So heating at 106 degrees, you will have less spores recovered. There will be more spores that are killed by this heat treatment, but we could see a very nice correlation of 10-fold, which means that if you heat at 100 degrees, you can still get the same interpretation, same predictability of spoilage, but you need to adjust your specifications 10-fold. So for instance, from 100 spores per gram to 1,000 spores per gram.
And so how will those findings be practical to producers of these products?
So I think one of the most important outcomes is that we now have scientific data available that underlies a lot of knowledge that people already had and were using internally, but they could never communicate about it because there was no data available. There was no reference. So now we have a publication which can be used as a reference to improve this communication, improve the understanding between suppliers and buyers, for instance. That is one big advantage. The other is certain companies can review their internal processes. Maybe they've been using a specific agar medium for decades just because they were always using it. Now with this extra knowledge that it may not support certain problematic spore-forming species, they may want to review whether they can switch to different mediums such as TSA and improve their risk assessment and predictability of spoilage. Another is there is an ISO initiative taking place at the moment for standardization of detection and enumeration of spores in all sorts of foods. And our results and data is perfect input for those communications and discussions on which direction to take in that standardization.
The work that you've done so far, you don't just stop that. What are the next steps in terms of more research on the subject?
Yes, indeed. So spores, there will always be variety. There's a lot of biological variety. Of course, there's lots of different species, but also we've seen that strains within the same species can also have a lot of variety in their behavior, either heat resistance or germination properties. So from a fundamental point of view, it's very interesting to understand what underlies this variety. In some cases, it can be a genetic component. In that sense, we can also think about development of, for instance, molecular methods to substantiate more classical plating methods for detection and risk assessment. There will always be this variety, and there's no one method that offers 100% predictability, but there will be research directions to help improve the predictability. And apart from that, spores are present everywhere. So we've now done a consortium on milk powders, but there's lots of different other ingredients that also they have their own additional issues. We're now in the process of a consortium project specifically on spores in cocoa powder, for instance. And with cocoa, it's a different process of production. And there are different spore species than with milk powder. And also cocoa has the extra complexity of hydration. So it's very difficult to hydrate the cocoa powder. So even very low numbers of spores can cause issues in UHT products. That's something that is not happening a lot with milk powders, for instance, because it's hydrated very nicely. So those are a few types of directions that we're doing further research on.
Seems like you're going to be busy for a little while yet then.
Well, yeah, as long as there are spores, I think we'll still be busy.
All right, that's good.